As we begin Unit 2, we are going to start with solving equations, but before we do that, we need to go over the vocabulary that is going to be used throughout this whole entire chapter. So part 1 is going to be defining algebraic properties, and there are several algebraic properties that are used when solving linear and quadratic and exponential functions. So the first property is the associative property of addition and multiplication. And that means you can associate or regroup terms. So for example, A plus B can be grouped plus C, or you could say A plus the quantity B plus C. Either way, you get the same answer. And the same works for multiplication. You can have the quantity A times B times C is equal to A times the quantity B times C. So the example I will give will be an addition example, and I'll say that the quantity of 1 plus 2 plus 3 is equal to the quantity of 1 plus the quantity 2 plus 3. And if you think about this, 1 plus 2 is 3, plus 3 equals 6. Or you could say 1 plus the quantity of 2 plus 3. Well, 2 plus 3 equals 5, plus 1 equals 6. So either way, the answer is 6. So we grouped the 1 and 2 here, and then in the second one, we grouped the 2 and 3, and that's the associative property. So you can come up with your own example right here so that you can remember the associative property. The second property of operations is the commutative property, and we've been talking about this a lot when we've been combining like terms. So we have A plus B equals B plus A, or A times B equals B times A. So it doesn't matter which order the terms are in for addition and multiplication. And commute means to move around your terms. So for example, we could have, I'll do a multiplication this time, we have 5 times 3 equals 3 times 5. 5 times 3 is 15, which is equal to 3 times 5, which is also 15. So go ahead and come up with your own example here. Additive inverses and multiplicative inverses. So for every A, there exists an A, so that A plus negative A equals negative A plus A, which is 0. So what that means is if you have a positive number and a negative number of the same number, the same absolute value, it is always going to add to 0, and then for every A, there is a 1 over A that equals 1. So we'll do 2 examples to make that a little bit easier. So you could say 2 plus negative 2 always equals 0. So 5 plus negative 5 equals 0, 10 plus negative 10 equals 0. So when you add the inverse, you're going to get 0. When you multiply, and you're going to multiply by the reciprocal, it's always going to equal 1. So 2 times 1 over 2 equals 1, or 5 times 1 over 5 equals 1. So when you multiply by the inverse, or the reciprocal, you're always going to get 1, but when you add, you're always going to get 0. This last property we've talked about several times, which is the distributive property. So we have A times the quantity B plus C, and that's equal to A times B plus A times C. So remember, when we distribute, we draw our little rainbows, and we're multiplying when we do that. So if you had 5 times 1 plus 2, that's equal to 5. 5 times 1 is 5, plus 5 times 2 is 10, and that'd be equal to 15. And you can see that because 1 plus 2 is 3, 5 times 3 is also equal to 15. So the distributive property always works. Some ways you might see this on an exam. So I put some USA test prep examples here. So this first one says, it is given that 2 times the quantity 3 plus x equals 6 plus 2x. This is an example of what property? So remember, the associative property is regrouping your terms, and it doesn't look like they regrouped any terms right here. The commutative property is the way that it's written, and it can be written as either way. So this is not the commutative property. Distributive property is the correct answer because you can see all they did was they multiplied 2 times 3 to get 6, and they multiplied 2 times x to get 2x. They distributed this 2 to inside this quantity to get this answer here. So that is an example of the distributive property. Identity property we never talked about, so you know that that can't be the right answer. So right here the answer is C. Another test prep example would be identify the missing justification. So this time they give you an equation, they solve the equation, and they want you to justify it with the properties. And this is the most common way that you would be tested on the properties here. So they have this equation, x plus 4x equals 32, plus 32 equals 12, and they say that's given. 5x plus 32 equals 12, and that's the one that they want to know, how did you get there? So associative property, remember that's just regrouping terms. Commutative is rearranging your terms. Distributive property is multiplying, and identity property we never talked about. So first I could cross out identity property. Distributive property, it doesn't look like they ever multiplied anything, so I know it's not distributive property. What happened was they combined my like terms. X plus 4x gives me this 5x. The 32 is a constant, so it stays the same. So did they regroup my terms, or did they move terms around? I would say that they regrouped terms. They grouped this x and 4x together to make 5x. So when they regroup terms, that's the associative property. So whenever they combine like terms, you're thinking the associative property. Perfect. So those are two examples of how you might see the properties of operations and the properties of algebraic expressions given to you on an exam or a quiz. On the next page, we have more properties that we need to go over, and these are the properties of equality. So these are the properties that are going to allow you to balance, manipulate, and solve equations. So hopefully you started solving equations in middle school, and this is more of a review than anything, but if not, that's totally fine. We're going to go through this whole packet that teaches you how to solve equations. So the first property is the reflexive property of equality, and that just means that A equals A. Whatever you have on either side of this equal sign means that they are equal to each other. And always a number is equal to itself. So 2 is equal to 2, 5 is equal to 5, -7 is equal to -7. So I'm going to give that example, -7 equals -7. That is true. It will always be true. The symmetric property of equality is if A equals B, then B equals A. So all you're doing is you're taking your equation and you're flipping it so that whatever was on the left is now on the right, and whatever was on the right is now on the left. So if the numbers are equal, they will still be equal if the order is changed. So -2 plus 1 is equal to -1 plus 0. And that'd be the same if you said -1 plus 0 is equal to -2 plus 1. All I did is I took what was on the left and put it on the right, and what was on the right and put it on the left. It's the exact same equation because there's an equal sign. The addition property of equality. So if A equals B, then A plus C equals B plus C. So if you add something to one side, you have to add it to the other. So on this equation, they added C to each side. So when you add the same number to both sides, your equation stays true. So if you had -2 equals -2, and you added 5 to both sides, then you would get 3 equals 3. So you have to add same number to both sides. That's the addition property of equality. The subtraction property of equality is very similar, but instead of adding the same number to both sides, you're going to subtract the same number from both sides. So if A equals B, then A minus C equals B minus C. So you subtract the same number from both sides. So if we started with 5 equals 5, I'd have to subtract the same number to keep it true. So if I subtract 2 from the left, I have to subtract 2 from the right. 5 minus 2 is 3 equals 5 minus 2 is 3. So this time you're subtracting the same number from both sides. Multiplication property of equality, same exact thing, but this time you're multiplying the same number by both sides. So you start out with A equals B, then A times C equals B times C. So if you started out with 2 equals 2, and you multiplied both sides by 3, 2 times 3 is 6, 2 times 3 is 6. And remember, we want both sides to be equal to each other. If they're not equal to each other, that means you made a small mistake somewhere. So this is the multiplication property of equality. Division property of equality, you guessed it, you divide by the same number on both sides. So if I started out with 10 equals 10, and I divide both sides by 2, 10 divided by 2 is 5, equals 10 divided by 2, 5. So whatever you do to one side, you have to do to the other. And that's going to be huge when we start solving equations. Okay, so substitution property of equality is a little bit different, but we have practiced substituting equations. We actually did that in Unit 1. So it says here, if A equals B, then B may be substituted for any A in the expression containing an A. So that just means you can substitute numbers into any equation. So if we had 5x equals, let's see, 3x plus 4, and they said that x equals 2, then we can plug in 2 everywhere we have an x. So 5 times 2 equals 3 times 2 plus 4. 5 times 2 equals 10, equals 3 times 2, which is 6 plus 4. 6 plus 4 equals 10, so that stays true. 10 equals 10. So basically all this says is if they give you a value, if they say x equals 2, then you can plug in 2 everywhere you have an x. That's the substitution property of equality. And again, I wanted to give you some examples of how you might see this on an exam or on your EOC. So number 1 says fill in the missing reason for the argument shown. So it says 5 times the quantity of 2x plus 4 is given. And then step 2, it says they use the distributive property. So 5 times 2x gives you 10x, 5 times 4 gives you 20, and they left this 50 right here. The question is, how did they get here to 10x equals 30? So this 20 went missing, and this 50 went to 30. So I want you to think about how they could have used one of these properties we just talked about to get rid of this 20, and this 50 went to 30. Well, I can tell that they did not multiply both sides by anything. This 10x stayed a 10x. If they would have multiplied, this 10x would have gotten bigger. So it's definitely not A. The division property of equality, again, this 10x stayed a 10x. If they would have divided by any number, this 10x would have changed. So it's not division. The transitive property, never heard of it. Can't be that. Subtraction property of equality. Now that's the only answer left, so we know that's the answer, but let's think about why. This 10x plus 20 turned into just a 10x, which means they subtracted 20 from here. This 50 went to 30, which means they subtracted 20 from here. So when you subtract 20 from one side, you have to subtract 20 from the other, which is how they got this 10x plus 30. Now they tell you they use the division property on this last step. If you divide both sides by 10, you get x equals 3. That's a one-step equation. Number 2 is very similar. It says give a reason for the last step in the argument shown. So it says 3 times the quantity x plus 4 equals 18. 3x plus 12 equals 18 using the distributive property. They subtracted 12 from both sides, so you got 3x on the left. 18 minus 12 is 6 on the right. But now we have x equals 2 as our answer. So we need to figure out, did they add, subtract, multiply, or divide to get from 3x minus 6 to x equals 2? Remember that this is a 3 times x, and the only way you could get rid of multiplication is to use division. So the correct answer here is B. They didn't add to both sides, they didn't multiply, they didn't subtract. What they did is they divided both sides by 3. 3x divided by 3 is x. 6 divided by 3 is 2. In the next video, we will practice using these properties of equality to solve one-step, two-step, and multi-step equations.